I've created a very small database in SPSS. So as you can see here, we have a number of variables. So essentially this is a very small sample of 20 students. We have their gender, three different measures of their satisfaction with their current course, and the section of the course that they're taking. So the purpose of this tutorial is to quickly show you some of the different ways that you can prepare your data before you can start doing the analyses. So one of the first things you want to do is make sure that you have properly uh, prepared your data files in terms of what SPSS can see. So in order to do that, you need to go to the variable view, and what you want to look at is the name of the variables. If you have any value labels that are assigned, you might want to just confirm that everything's here. So for gender, for example, we have 1 and 2 for codes for men and women, and the sections, oops, sorry, if I click here, we see for the sections that you can be in section A, B, or C, and those have also been given a code. The satisfaction scores go from 1, not satisfied, to 5, very satisfied. However, you don't need to code that. Usually that's pretty intuitive. But what is important is letting SPSS know what type of variables we're dealing with here. So gender, and then we have the 3 different scale variables, and then finally the course section. So course section, since there isn't necessarily one that's better than the other, just categories, we need to make sure that it is marked as nominal. Okay, so that being said, we can proceed with the first step, where we just want to visually inspect our data to make sure that nothing is going on. It looks like I accidentally added a variable there. So when you're visually inspecting the data, what you're looking for are any kind of unusual response patterns. So it's pretty easy with a sample of 20 and just 5 variables. However, this can get quite overwhelming and difficult to spot as your sample increases. So what you'd be looking for is someone who looks like they didn't really pay attention to the questions and just might have answered something for the sake of answering and finishing the survey. So I purposely coded participant 16 here with just ones across the board. So this is something that you might want to flag, since it is a little suspicious, just, everything. However, for this particular sample, we don't really have enough data to confirm, but it's something to watch for. So if later on, there are issues, you might want to consider try rerunning things without this participant in it. Okay, that being said, once you've kind of visually looked at the data, the next thing you need to look for are impossible values or typos or scores that are out of range. So the much easier way to do this is actually just through the frequencies option. So if we click on Analyze, Descriptives, and Frequencies, and we can actually select all the variables in our data set that we're interested in looking at, and once we click OK, we'll automatically get a copy of all the information. So what we can see here is a summary of everything. So we know that we have no missing data on gender. For satisfaction 1, we have some missing data, and on the course section we also have missing data. So that means that we have to deal with that. And then if we look a little closer, we can see that for gender we have 8 men and 10 women. However, we also have 2 unusual values here, 3 and 4. So these are obviously errors of some kind, since we don't have a 3rd and 4th gender category in this data set. So this is something we'll have to go look at a little bit closer. And then here everything is fine. We have 1 to 5, 1 to 5, 1 to 5, and again there. Okay, everything's alright. We just have the 3 courses selected. So what we've seen here is we have some missing data we need to address, and some out of range or impossible values right here in gender. So let's start with the impossible gender, or these things here, and then we'll move on to the what to do with the missing data. So close this. Looking at gender, the easiest way to see the problem is to just sort your variable by. So if a particular value, so you can either go lowest to highest or highest to lowest. If you right click on it, you have that option right here. So by sorting it ascending, we automatically put our two out of range values right here. So on a categorical variable like gender and on demographic information, we can't impute a new data or do any or new value or change any information. So we have no code or no choice but to code something like this as missing. So what we can do is actually delete it and replace it with a score of 99 or any value that you would like. And then we go back to our variable view and make sure that we let SPSS know that 99 is a missing variable. So that's done. Okay, the other issue we had was some actual missing data on satisfaction 1, I think it was. Yep, I can see it right there. And also section. So we'll deal with section first since it is a categorical variable. So it's pretty straightforward. We can't really do anything about this other than code it officially as missing. So we'll put in 99 in there as well. Go back here. Make sure SPSS knows that 99 means that it's missing. And then that one's dealt with. So the great thing with continuous data is that we do have some options in terms of saving this observation. So in cases when we're not dealing with a categorical variable, we can actually replace this value here with the average for the entire variable. So what we would like to do is first we have to calculate the average for the whole group on satisfaction 1. That's pretty easy. We go to Analyze, Descriptives, and either way, frequencies or descriptives can get there. For right now, we'll just click Descriptives. So interested in satisfaction 1. If you click here, you'll see that average is already automatically selected. And then we click OK, and the output opens. And what you can see here is that the average is 3. Okay, so we have scores ranging from 1 to 5, standard deviation of 1.33, and an average score of 3. So what this means is that we will replace our we'll replace this missing value with that average score. So we go right here, and we'll just replace that with a 3. Okay. So essentially we've looked at the data set. Like I said, this will be a much larger step or process when we're dealing with a bigger data set. However, we've done the initial kind of inspection for out of range or impossible values, and also we've looked at the missing data and the response sets. So now the next thing we want to do is look at calculating the reliability for any scales or values that we might want to combine to create one measure. So satisfaction 1, 2, and 3 are all measures of the student satisfaction in the course, and the 3 of them can be combined into one measure. All 3 questions were worded in the same way, so there's no need to recode anything. So if you recall, recoding is when you would switch this value, like a 1 becomes a 5, a 2 becomes a 4, etc. And that's in cases when one of the questions was negatively worded. But in this case, we don't need to. All 3, we're saying, for the example's sake, are already in the right direction. So before we can actually combine these 3 into one measure, we do need to make sure that there is some consistency between these 3 measures. So that can be done through the reliability calculation option. So if you click on Analyze, go down to Scale, and hit Reliability Analysis, the option for this analysis will appear here, and it's very easy. So you would select the variables that you're interested in confirming are in fact reliable. So you don't actually need to select anything from this option here, so I'm just showing you it. This option sometimes is interesting if you have lots of items, so it'll tell you how the variable or how the reliability will change if different variables are removed from the calculation. However, for this one we only have 3, so we don't need it. So that being said, we can click OK. And actually, surprisingly, I just entered random numbers. The reliability isn't bad. So you see here that we have a 0.609. So anything above 0.5 is borderline okay. 0.6 is moving in the right direction. It'd be nice if we'd had something above 0.7. However, 0.6 isn't bad for having randomly entered numbers. So essentially this would be the internal consistency value here. And as you can see, this is the number of items, so the number of variables that were included in that measure. So since this is acceptable, we will move forward and actually calculate an average score of satisfaction with the course. Now, in real life, so if you want to publish your data, if you didn't have a good reliability value here, you'd have some problems to have to address them. For the purpose of our course, you're going to move forward anyway, even if this is bad. So that being said, now we will combine these three into one. So we can do that with the transform compute option, and we're looking at creating a mean, so of satisfaction. And as you, if you're already familiar with SPSS, you should know that you can do it with one of the function group formulas. So it would look something like this. Or you can do the version that would look more like a traditional calculator, where you would open brackets, do 1 plus 2 plus 3, close brackets, and divide by the total number. I've just noticed I have a little typo here, though, wow, and I did the same one here, sorry. I'll have to actually I'll have to come back, so I'll have to fix my variable name. There we go. All right, let's go back to the calculator. And so we have mean, open bracket, 1, 2, 3, and we can click OK. And SPSS confirms it's creating us our new variable that represents everyone's average score on their satisfaction with the course. And there it is. So we see we have a nice range here. So now the next thing that we're interested in examining is whether we have any outliers. So if you recall, we can do that by converting these scores into z-scores, and then using the cutoff of plus or minus 1.96, we can see if we have any scores that need to be addressed. So obtaining the z-scores is very easy. You go to Analyze, Descriptive Statistics, and then click Descriptives again. And essentially, you click the variable that you're interested in examining, and then you select the box here that says Save Standardized Values as Variables. And what this is going to do is it's going to create a new variable in SPSS that has the same name as the variable we've selected, but it's going to add a little z. And what it has done is taken each of the scores we had on that variable and has calculated the equivalent z-score based on the average of this variable and the standard deviation and this observed score. So we click OK. So at the same time, we do get a quick summary of the variable. We can close that. And when we go back to SPSS, we see right here that we have the range of scores. So if we sort them ascending, we have a variety ranging from minus 2.4 to plus 1.82. So if you recall, we're using the cutoff of plus or minus 1.96 to identify unusual scores, and judging by this, participant 16 would be an outlier because this score is smaller than 1.96. So the option to deal with this outlier is to replace this value here with the next closest value. So on this variable, that would be in range. So judging by the fact that this value here is associated with a z-score of minus 1.28, the replacement value is going to be somewhere between these two, so somewhere between 1 and 2. And we can calculate the exact value actually by using the standard deviation and the mean of this variable, and we can go from there. So first thing we need is the mean and standard deviation of this score. So I'll just go back to the descriptive statistics, and I'll unselect this box. I accidentally closed it. It already had given us this information, but we'll do it again. So click OK. And now, so we have the information here. Sorry, just grabbing a calculator. Okay, so in order to obtain or to confirm what the value is that we need to replace the z-score with, we need to take our standard deviation and multiply it by the z-score that we're looking for, and then add the mean. So we're interested in, so we have minus 1 point, oh, oops, sorry, so the z-score we're looking at is minus 1.95, and we need to multiply that by the standard deviation, which is 0.86. So that gives us so negative 1.677, and then we want to be subtracting that from the mean. So we can add 3.1, and it gives us 1.43. So if you recall, I'd said it's going to be somewhere between 1 and 2, so that exact value is 1.43, and now we have replaced the outlier score with a score that is just in bounds. So the equivalent of this score now would look something like this. Okay, so it's just within that cutoff of 1.96. So one thing to note is that if you rerun this analysis here with getting the z-scores, it's going to adjust accordingly, and it'll redistribute everything based on your new values. So it is possible that more outliers will be identified. However, you would stop just after doing it once. So once this has been corrected, the next thing we can look at is the normality of our variable. So we can start by looking at how it is, at looking at a quick graph to see what we're dealing with. So if we go to Chart Builder, click OK, and then select the histogram right here. There we are. And then we'll take our mean variable for satisfaction, click OK. And then we should have our chart loading. Perfect. So this is the distribution of our scores. So we do have some holes missing here. So it doesn't look particularly skewed, but I do think that we're going to have some issues with our kurtosis. So since we don't have a particularly large sample size, we'll have to take a look at the ratios, the skewness and kurtosis ratios. So we close this. To obtain those values, again, it's very easy. We're going to go and analyze, descriptives. Again, you can do frequencies or descriptives. And this time we're interested in the skewness and kurtosis. So SPSS will automatically, when we do this, give us the value and as well as the error for each of those, so that you can calculate your ratio by hand. So if I click OK, and mean satisfaction's already been selected, and OK, new window opens, and as you can see, we have added additional columns here. So we have the skewness and the kurtosis on both ends. So what we're looking at, if we grab our calculator, is whether the ratio of these two values exceeds the cutoff. And for this one, we'll use a larger value of 3.28. However, I might be a little bit off in that, and so it may be slightly different, but just refer to the table or the PowerPoints about what value to use. So we would calculate it for doing skewness 2.49 divided by 0.512, and it gives us 0.048, so no problems there. So skewness, not an issue. Then we take the other one, so we've got 0.534 divided by 0.992, and again, no issues whatsoever. So we're at 0.5. So we can in fact say that this variable here does in fact have a normal distribution. So those are the different steps you need to take in order to prepare your data for analysis. If you have any questions, please not hesitate to ask, and you should be equipped with this information to conduct the lab assignment for this tutorial, as well as the first assignment for this course. Thank you very much.